Hello everyone, this is Pragati, studying in Sri Venkateshwara College of Engineering in 3rd SEM ISC. Today's my subject is data structures, topic is additional list operation, spark matrix and double linked list. And my first topic is additional list operation, operations for chain. It is often necessary and desirable to build a variety of functions from manipulating single linked list, which get and return nodes to the available space list. Inverting a chain in another useful operation. This is basic program for operations of chain. Type def structure node, list operation, type def structure, open parenthesis, character data, list pointer link, and close parenthesis. Next we see the using used to extra pointers, middle and trial, inverting a single linked list. This is programmed to invert a single linked list. List pointer invert, list pointer let, middle plus null, while let, open parenthesis, trial is equal to middle, middle is equal to let is equal to let is link, middle to link is equal to trial, close parenthesis, return middle and close parenthesis. Next we see circularly linked list. What is circular linked list? Circular linked list is a variation of linked list in which the first element points to the next element and the last element points to the first element. Both singly and double linked list can be made into a circular linked list. A circular linked list can be used to help travel the same list again and again in Node. Types of circular linked list, single linked list and double linked list. In single linked list, the last node point to the first node and there is only linked between the nodes of linked list. Double linked list, the last node points to the first node and there are two linked between the nodes of linked list. Next, advantages of circular linked list. Any node can be a starting point. We can traverse the whole list by starting from any. We just need to stop when the first visited node is visiting again. Circular lists are useful in applications to repeatable go around the list. For example, when multiple applications are running on a PC, it is common to the operating system to put the running application on a list and then to cycle through them, giving each of them a slice of time to execute and then making them wait while the CPU is giving to another application. It is converted for the operating system to use a circular list so that when it reaches the end of the list, it can cycle around of the front of the list. Circular double linked lists are used for implementation of advanced data structure like Fibonacci's 8. Disadvantages of circular linked list. Depending on the implementation, inserting at start of list would require doing a search for least node while which could be expensive. Finding end of the list and loop control in hard. What is sparse matrix? Sparse matrix is a matrix in which most of the element are zero. By contrast, if the most elements are non-zero, then matrix is dense. Sparsity or sparse matrix is the number of zero valid element divided by total number of elements. The following sparse matrix consists only 60 non-zero elements with 84 zero elements. Its sparsity is 84% and the density is 16%. Representation of sparse matrix. The representation of sparse matrix will be a triplet only, in the sense that basically the sparse matrix means very few non-zero elements having in it rest of the sparks are having the values 0, which are basically useless values or simply empty values. So in this efficient representation we will consider all the non-zero values along with their positions in a rows which representation of matrix. The zeroth row will store total rows of the matrix, total columns of the matrix, and total non-zero values. This is example for space matrix includes studio.h. This includes the standard input output library and define maximum size 10 defines a macro maximum size which a value of 10 representing the maximum size of the space matrix. Structure to represent a space matrix element. Structure element int row, int column, int value. Defines a structure element to represent a non-zero elements in the space matrix. It stores the rows, columns, and value of the element. Function of input space matrix. Void input space matrix. Struct element space matrix input row and input column takes a one-dimensional array of elements, structures the number of rows and the number of columns as input. It promotes the user to input elements for a matrix and store non-zero elements in the space matrix format. Int k is equal to 0 for I. Int I is equal to 0. I is less than row plus plus I, and for I j is equal to 0, j is less than column plus plus j. Int element scanf percentage d and element. Store non-zero elements in the sparse matrix. In this, it will store the non-zero elements if of element is not equal to 0, space matrix row is equal to I, space matrix column is equal to j, space matrix volume is equal to element plus plus k, and all close parenthesis, and it is function to display space matrix void display space matrix of struct element space matrix int column. Printf space matrix slash n. Printf rows, column, and value. For int is equal to 0, I is less than count plus plus I. Printf percentage d slash t, percentage d slash t, percentage d slash t. Sparse matrix row, comma, sparse matrix column, sparse matrix value and close parenthesis. Next, int I. This is declares variable rows and columns for store the number of rows and columns as the number of input the number of rows and column declared an array of element structure call space matrix with matrix size of max size. Call the input space matrix functions of input. The space matrix calls the display space matrix function of display the space matrix. Here we see the int main, int row column, printf enter the number of rows and columns of the matrix, space scanf percentage d and percentage d because rows and columns, row and column, structure element space matrix maximum size. In space matrix, rows and column, display space matrix, rows into column, and return 0. Introduction to double linked list. Double linked list is a variation of linked list in which navigation is possible in both way, either forward and backward, easy as compared to single linked list. Next, these are the concept to understand the operations of double linked list. In double linked list, insertion, deletion, and traversing is there. Insertion at first insert, at last insert, had desired insert. Delete first, last, and desired. Traversing lookup. Insertion adds a new node to the front first. Deletion remove a node from the last starting. Insert last adds a new node to the last ending. Delete last remove a node from the last ending. Insert after adds a node after a least item. Delete using the keyword removes a node from the last. Display forward shows the entire list in a forward fashion. Display backward shows of the entire list. A node in a double linked list has at last three fields, a left link field and data field, and a right link field. The necessary declaration or type def struct node into node print. Print def struct open parenthesis node print link element data node print r r link and close parenthesis node. Thank you.